The paper of the day is Spark, Cluster Computing with Working Sets. Spark provides three simple data abstractions for programming clusters: resilient distributed data sets, RDDs in short, and two restricted types of shared variables: broadcast variables and accumulators. While these abstractions are limited, we have found that they are powerful enough to express several applications that pose challenges for existing cluster computing frameworks, including iterative and interactive computations. Furthermore, authors believe that the core idea behind RDDs of a dataset handled that has enough information to reconstruct the dataset from data available in reliable storage may prove useful in developing other abstractions for programming clusters. Paper shared results of three experiments that show its promise as a cluster computing framework. First, logistic regression. Compared the performance of the logistic regression job to an implementation of logistic regression for Hadoop using a 29 gigabytes dataset on 20 M1X large EC2 node with 4 cores each. With Hadoop, each iteration takes 127 seconds because it runs as an independent MapReduce job. With Spark, the first iteration takes 174 seconds, likely due to using Scala instead of Java, but subsequent iteration takes only 6 seconds, each because they reuse cache data. This allows the job to run up to 10 times faster. Second, alternating least squares. Spark improved performance by 2.8x in an experiment with 5,000 movies and 15,000 users on a 30-node EC2 cluster. Third, interactive Spark. They used the Spark interpreter to load a 39 gigabytes dump of Wikipedia in memory across 15 M1X large EC2 machines and query it interactively. The first time the dataset is queried, it roughly takes 35 seconds compared to running a Hadoop job on. However, subsequent queries take only about 0.5 to 1 seconds even if they scan all the data. This provides a qualitatively different experience compared to working with local data. Let's talk contributions. Authors believe the Spark is the first system to allow an efficient general-purpose programming language to be used interactively to process large data sets on a cluster. Early Spark experience with the system is encouraging. Papers show that Spark can outperform Hadoop by 10 times in iterative machine learning workloads and can be used interactively to scan a 39 gigabyte dataset with sub-second latency. Coming to PS score, overall this paper is nice and engaging read, so it gets 9 out of 10 on readability. With 17 pages long, it scores 7 out of 10 on length. The description of the approach is decent but easy to follow for most part, but lacks interesting details at some places, so that makes it 7 out of 10. Industry value and learning meter is very high, so it gets 10 out of 10 on each. Overall PS score is 9 out of 10.